Lesson 16 is graphs of sine functions, and in 16.1 we're going to learn about the midline and the amplitude of a sine function. Before we do that, we're going to graph the parent function for sine, which is f of theta equals sine of theta, and theta is just our input value. You could easily replace it with x. It's just theta is something that's commonly used to as a variable for an unknown angle, which we're going to be working with angles in the unit circle here. So we'll make our input-output table. You can see all of the input values, those are across the top. Those are in terms of theta. All of our output values will go on the bottom. Those will be y. And then before we can get our values for the table, we have to remember how to find sine from the unit circle. And from the unit circle, sine is equal to y. We learned it as initially y over r was opposite over hypotenuse, but in the unit circle, r is 1. So it just simplifies down to y. So that means for each of our input values, we're going to find that angle around the circle and look for the y-coordinate from the point at that angle. So the first one is angle of 0 radians, which is right here. And then we take the y-coordinate from that point, which is 0. So we put a 0 right here. And then the next angle is pi over 2, which is right here. We're taking sine, so we'll be specifically looking for the y-coordinate, which was 1 right there, so we'll put a 1 right there. And then the next angle is pi, which is right here. And then again, looking for the y-coordinate only, since it's sine. The y-coordinate is 0, so we'll put a 0 right here. Next angle is 3 pi over 2. Which is down here, and then we're looking for the y-coordinate, which is -1 right there, so we'll put a -1 right here. And then the last angle measurement is 2 pi, which is just going to be one full rotation around the circle, so it's going to be back at 0, and that means it's going to have the same y-coordinate as that angle 0, which is just 0, so we would put a 0 right here. And you could technically do all the input values around the unit circle. It would take a bit longer, but it would give you some more points in between. But these 5 points are the main ones we want to focus on for the sketch of our graphs. So next we'll graph f of theta equals sine of theta. We're going to draw an x and y axis, and it's going to look a little bit different than you're probably used to drawing it. So you want to draw the vertical axis kind of more shifted to the left, so it's shaped like this. And then what's normally our x-axis is what we use to describe the input, but in this case the input is not x, it's theta. So we wouldn't label it with x, we would label it with theta, and that just means our angle input. And then the vertical axis is our output, which is still y, or you could put it as f of theta if you prefer. And then now we just need to go ahead and scale our horizontal axis. So you could see on our table there's 5 input values, but one of them's at 0, so we don't need to put a tick mark for that. So we really just need to do 4. And so we just need to break it down into 4 even kind of tick marks. I'm really bad at drawing even spaces, so the way I like to do it is I like to draw one far one, and then I like to cut that in half, and then I cut each half in half, and then all of a sudden you have 4. If you have a hard time with the spacing, you can do it the same way. Okay, so now we'll go ahead and label it. So we have 0 right here, and then the first one after 0 is pi over 2. The next one is pi. The next one is 3 pi over 2. And then the last one is 2 pi. And then in our output, it kind of cycles between, it goes from 0 to +1, and then down to 0, down to -1. But our highest number is 1, our lowest number is -1 from that bottom row of the table. So for our y-axis, we just need to do 1 mark at +1 and then 1 mark at -1. And then now we're ready to graph each point. So the first point is, and remember that each of these together is a point, so it'd be 0, 0, pi over 2, comma 1, and then pi 0, and so on. So our first point is at 0, 0. So right here. From this point, and then our next point is pi over 2, 1, so we'd go to pi over 2 and then go up 1. And then our next point is pi 0, so we would go over to pi, but we wouldn't go up or down at all since the y-coordinate is 0. And then our next number is 3 pi over 2, -1, so we'd go all the way to the right to 3 pi over 2, and then we'd go down 1. And then our last point is 2 pi and then 0. So we'd go to 2 pi, and then we wouldn't go up or down at all. We would just put a point exactly on there since the y-coordinate was 0. And then next we're going to connect our points, and it's like a curve that kind of snakes through it, like oscillates between those. So it looks something not like that. It looks kind of like this. I'm not that good at drawing them, but it's like a nice smooth curve. And then we have a few key points that I kind of want to point out on here. And this is, like I said, this is the parent function. So like the objective would be to get really comfortable with this, and then we'll make modifications to this graph to get to like any new function that we have. So with sine functions, we're going to talk about like what the midline is more specifically in a second, how you can find it. But you can see like this graph has a very significant like middle point. So like on the parent function, it's right here. So sine functions begin at that midline. And again, we'll go over like how to find out a formula for it in a sec for like all functions. But the midline just cuts the graph in half. And sine functions start at the midline. It's really important to know that because not all functions will start there. And that's kind of how you identify if it's sine or not. So we'll say, so I have to zoom way in. We'll say sine starts at midline. And when it says like starts, I mean the graph does continue like this way, but it's like it has a y-intercept at the midline. So sine starts at the midline. And then from the midline, it goes up to its highest point. So if we look at this one right here, that's the highest point on the entire graph. Like it won't go any higher than that. It was the largest value on our table. So that's called a maximum. And then after that, it goes back down towards the midline again. After it hits that midline, it goes down to its lowest point on the entire graph, lowest point on the table. So that was a minimum. And then after that, it goes back towards the midline again right here. And then that's going to be like one full rotation. Everything after that is going to continue to repeat itself because we got these points from like one rotation around the circle. So if you keep going around the circle, you're going to end up with the same exact numbers, and the graph is just going to repeat itself over and over again as it continues on to the right. Okay, so moving down, this is a more like kind of detailed version of the parent function. The one up above are like the key points that you need to know and you're going to be able or need to be able to graph. This one actually has all of the points from the unit circle. So what I mean by that is like, let's say instead of just doing those like 5 points, I don't know, we had to find the pi over 4.2 for sine, and pi over 4 has a y-coordinate of root 2 over 2. That would end up being this point right here. So that has, this graph down here has every single little like radian measure from the unit circle on there. You won't ever have to graph every single one, but it is kind of nice to see like how it curves and where all those individual points come from. Okay, so moving down to two new vocab. I know we already kind of talked about the midline, but all sine functions have a like amplitude and a midline. And for amplitude is the distance that the like kind of max or the min is away from the midline. And you can find it by taking the highest y value and subtracting the lowest y value and then dividing by 2. So I'm just going to kind of show like from this graph how we would find it. So the highest y value is right here. The lowest y value is right there. It's like the highest point and the lowest point on the graph. So this is at 1 is the y coordinate. You see 1 right here. This is at -1 right here for the lowest point. So if I were to take those two values and put them into this formula, it would be the highest y value, which is 1, minus the lowest y value, which is -1, and then divide it by 2. And then 1 minus -1 turns into like 1 plus 1 because you have the double negative, which is 2 over 2. and then 2 over 2 simplifies to just 1. So this graph would have an amplitude of 1. And then to find the midline can be found a couple different ways. One of them is by taking the lowest y value and adding the amplitude. So that's this one right here. The other one is by taking the highest y value and subtracting the amplitude. It makes no difference. Just pick whichever one you want to use. So let's say I use this one right here. It would be y equals the lowest y value, which was that -1. And then we're going to add the amplitude, which the amplitude was just +1. And then -1 plus +1 is y equals 0. So our midline for this one would be y equals 0. And if I were to draw that on my graph, it's just this line right here. So y equals is always a horizontal line. And then if it's y equals 0, it's crossing 0 on the y-axis. But keep in mind, like, these formulas are really nice to have as a backup. But most of the time, you can, and I would prefer if you did identify the amplitude and the midline from the graph. So the midline is kind of what it sounds like. It's a horizontal line that cuts the graph in half. So if you can kind of eyeball, like, what is the halfway point between the maximum, the highest point, and the minimum, the lowest point? If you can see that, which sometimes you can't eyeball it, like it's kind of hard with the graph, but if you can see it, then you can label that as the midline. So we can see right here is our midline at y equals 0. And then the amplitude is the distance from the midline to the highest or the lowest point. So like from here up, this would be the amplitude. Or from here down is the amplitude as well. And again, it's just like a distance. So the amplitude is always going to be positive. It's the distance from the midline up to the highest point or down to the lowest point. And you can see right here, these are 1 unit each. And that's the amplitude we got using the formula. So the formulas are always there for you to fall back on, but you don't necessarily always have to use them. Okay, example 1, find the amplitude and the midline of the sine function. So I'm going to show it just by like picking it out on the graph first, I think, and then I'll go back and use the formulas as an example. So if I can figure out like what is the middle point between the highest point on my graph, which is 2, and the lowest point on my graph, which is -4, that's going to be my midline. And if you want to find the middle point, like using a little expression, middle point just means average. So you would do like 2, the highest point, plus the lowest point, which is -4, which 2 plus -4 is -2. And then to find the average of two numbers, you have to divide them by 2. So it ended up being -1. So the midpoint would be -1, or you could just count that on the graph. Like you can count the units. So from the highest point to the lowest point, you're going down 1, 2, 3, 4, 5, 6. So halfway would be 3. So if I go 3 units down, that brings me right here. So the midpoint would be, the midline would be right here. And it's always a horizontal line, so y equals, and then it's whatever it crosses the y-axis at, which is at -1. So midline would be at y equals -1. And then the amplitude is the distance from the midline to the maximum or the minimum. So if I'm going from here up, that's 1, 2, 3 units. So 3 units would be the amplitude. So that's what I mean by like you don't have to use the formulas. You can just eyeball it from the graph if you feel comfortable, but the formulas are always there. So for amplitude, the formula is you take the highest y value, which was right here at 2, and then you subtract the lowest y value, which was down here at -4. So 2 minus -4, and then you divide that by 2. 2 minus -4 turns into 2 plus 4. So then 2 plus 4 would be 6, and then you would divide 6 by 2 to get 3. So we ended up with the same number, 3, for our amplitude. And then for the midline, it's y equals, and you take either your lowest number and you add the amplitude, or lowest y value and you add the amplitude, or the highest y value and you subtract the amplitude. So I'm going to take my highest y value this time, which was 2, and then subtract my amplitude, which was 3, and then 2 minus 3 is -1, so we end up with y equals -1 for our midline. So it's the same answers we got from eyeballing it. It's definitely good to save the formulas though, I will say, because some graphs are kind of hard to tell just by looking at them. Okay, 16.2, the period and frequency of a sine function. So a couple new kind of like vocab. So the period of a wave is the horizontal length of one cycle of the wave. The following image represents one cycle of a sine wave. So a sine wave is going to continue like forever and ever. So right here, from here to here to here to here, right there, that's one like period. That's one length before it starts to repeat itself, because after that it would go up, come back down, and just be the same pattern over and over again. So the period is just one kind of rotation of the pattern, and it happens from like one rotation around the unit circle. So in the parent sine function f of theta equals sine of theta, the period of one cycle is 2 pi, because 2 pi is the Brayton measure of a circle. So like one full rotation around the circle is 2 pi. One full kind of rotation on the sine graph is going to be 2 pi as well, because after that one full rotation it starts to repeat itself. The frequency of a sine wave is the number of cycles that occur within a distance of 2 pi. So how many times is it kind of rotating around within 2 pi? In the parent function, the frequency is 1, because one cycle occurs from 0 to 2 pi. So there can be different kind of like changes that happen in the graph that make the graph like rotate more quickly or less quickly, and that would change the frequency. So example 1, find the frequency and the period of the time of the sine function. So right here it says the frequency of a sine wave is the number of cycles that occur within a distance of 2 pi. So if we look at the graph, I know it's kind of small, but 0 is right here, 2 pi is right here. So we want to figure out how many like of the same kind of rotations, or how many repeating rotations are happening. So I have like starting from here to here, and it goes like up, goes back down, and then back to the starting point. So that's 1, 2, 3, 4, and then if you notice, like we're going from 0 to pi and we got 4, you can double that to get 8, or you can just keep drawing it. So another 5, 6, 7, and then 8. So between 0 to 2 pi, the pattern is repeating itself 8 times. And we know that the pattern is repeating itself because, you know, it starts like upward, starts going upward, comes back down, and then goes down and comes back up. And then it starts again with the same up and then down, up and then down, up and then down, and so on is the pattern. So there's 8 of those patterns happening within that like 0 to 2 pi. So the frequency is 8. So just to read like through that form or that definition for frequency one more time, the frequency of a sine wave is the number of cycles that occur within a distance of 2 pi. So 8 cycles occurred within a distance of 2 pi. And then next, the period is, I'm going to go back up to the definition up here. It says the period is of a wave is the horizontal length of one cycle of the wave. So here, like we know that from here to here, there was, sorry, that's very crooked. From here to here, there was 8 different waves. And in that distance is 2 pi. So if we want to find the length of like one rotation, we need to find 1/8 of 2 pi. Because like if there's 8 total in that distance, we can find 1 out of those 8 of that total distance 2 pi to find the period. So we would do 1/8 times 2 pi. You can multiply straight across and then reduce. So 1 times 2 pi is 2 pi over 8, and then 2 and 8 have a common factor of 2, so I could divide both by 2 2 divided by 2 becomes 1. 8 divided by 2 becomes 4. So this becomes pi over 4. And then this is a formula that you can use to find the period. I know it's kind of like nice always to have a formula to fall back on. So you can find the period by taking 1 over the frequency and multiplying it by 2 pi. So definitely save this. It'll come in handy. If you feel comfortable doing it this way though, that's totally fine. Just know that there's the formula there to fall back on. But what we did from like here is the same thing as the formula. We just hadn't really like named it yet. Okay, 16.3, how to graph sine functions. So there's a general form for sine functions. It's y equals a times sine b of x minus h plus k. A is going to be the amplitude in this case. B is going to represent the frequency. K is the midline. It's also like a vertical shift still, so that's still the same. And then H is a horizontal shift. That's something that we're going to learn in a future lesson, so you don't have to worry about a horizontal shift today. So example 1, graph y equals 2 sine of x plus 4. So we want to find amplitude, frequency, midline, and period. So the amplitude is A, it's the number in front, so our amplitude is going to be 2. And then the frequency is B, it's the number that comes between sine and x or sine and like theta, and there's no number there, so that would mean that the frequency is 1. If there's no number between sine and x, then the frequency or B would be 1. And then the midline is K, which is the number that's added like after the x in the parentheses. And there's a 4 there. So the midline is supposed to be a horizontal line, so we'd write it as y equals 4. And then for the period, we use this formula up here. So it would be, for period would be equal to 1 over the frequency, which the frequency was 1, that was B. And then times 2 pi, so this one's not too bad. 1 over 1 is just 1, and then 1 times 2 pi is just 2 pi. So that means that like if we don't have a number here, it's going to be kind of the same as the parent function when we go to draw it. Okay, so, or at least the period will be the same as the parent function. Okay, so when we go to draw it, kind of draw this like the same graph we drew from scratch where you shift the vertical axis kind of way off to the left. And then I like to scale my x-axis first, and that's of course the horizontal one, and I like to scale it the same way I talked about it before. So go like kind of to the end, and then we want to break it up into fourths so that we would have like room for the 5 main points of our kind of graph. Really need 5 every time. So make one far tick mark, and then we'll break it into fourths. So you'd put a halfway point, and then like a quarter of the way, and then a 3/4 to get them to be even. And then the like period is telling you how far like one full cycle goes. So that's really like going to be the end of your graph. Not like the total end, but like of what you have to draw. The period is going to tell you the last point you need to put up there. So our furthest most point is going to be 2 pi. And then we're going to break everything into fourths. Because this is the same as the period of the parent function, we don't really have to make any changes. So it's going to be the same as how we scaled this graph right here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because that's breaking 0 to 2 pi into fourths. And if you ever forget it, you can do the halfway, would be 1 pi. Between 0 and 1 pi would be half pi, so that's pi over 2. And then between pi and 2 pi was like 1.5, so that's 3 pi over 2. And then we can go ahead and put our midline on the graph already. Actually, I'm going to extend this line up just because I kind of blanked on our midline being a little bit higher than the parent function. And then now we can go ahead and put our midline and kind of scale our y-axis. So when we're scaling it, we have to consider, so our midline is at 4. That's going to be in the middle of the graph. but our amplitude is 2, so our graph is going to go like 2 above the midline and 2 below the midline, so just make sure you give yourself enough room for that. So if it goes 2 above the midline, I'm going to have to go all the way up to 6, so I would do like 1, 2, 3, 4, 5, 6. And then I'm going to go ahead and put the midline on there. Like we said, it's at 4, so this is just each tick mark is worth 1. Our midline is at y equals 4, so 1, 2, 3, 4, it'll be right here. And the midline really just helps to draw the graph correctly, so you always want to put it on there. So this is y equals 4. And then now we're ready to go ahead and draw our graph. So this is where knowing the shape of the graph is super important. So we know that sine starts at the midline, so the y-intercept is going to be on the midline. I think I'm going to do this in a different color. So the y-intercept is going to be on the midline, and then from there, it goes up to its maximum, which is it's the amplitude above the midline, and our amplitude is 2. So the maximum is going to be at pi over 2, and then 2 units above the midline up there. After that, it's going to go back down to the midline for pi, and then it's going to go down to a minimum, which is going to be 2 units below the midline. So you would count 2 units below the midline, that would be at y equals 2, and then we would go back up to the midline. And then those are the 5 points that we need for our graph. I'm going to show you one other order that I sometimes like to use when I'm graphing sine or cosine for that matter. So for sine, actually, hold on. So for sine, you can see that there is 1, 2, 3 points on the midline. Sometimes I like to just graph those right away. So they happen at the start where that point is. It happens at the end of the period at 2 pi, and then it happens in the middle. So you have, for sine, you have 3 points on the midline, start, middle, finish. And then at the kind of quarter of the way mark, sine goes up to a maximum, which is going to be the amplitude above the midline up here. And then at the 3/4 of the way, or 75% of the way through at that 3 pi over 2, you're at the minimum, which is going to be 2 units below the midline, the amplitude below the midline, so it'd be down here. So that's another kind of order that you can draw it in that's sometimes helpful. And then now we're ready to connect our points. And then that's it. Really just need 5. And then like I said, when you scale your x-axis, you're going to scale it pretty much like that. The main change that will happen will be if you have to, instead of going from 0 to 2 pi, if you're going from 0 to pi or something, depending on what the period is, you would break down those numbers a little bit differently, but you would still put the same amount of tick marks every single time. So 1, 2, 3, 4 marks on the x-axis every time, and break it down into fourths. Okay, so example 2, this is the last one. So write a function to represent the graph using y equals a times sine b of x plus k. Notice there's no h in here, and that's because we're not going to deal with any horizontal shifts yet. So in order to write this, we have to find amplitude, frequency, midline, and period. You don't need to find them in that order. I'm going to go ahead and just find the midline by finding the middle point on the graph. So the highest point on the graph is at 3. The lowest point on the graph is at -5. You could average those two numbers, or you could count the distance between them and find the middle that way. So the distance from 3 to -5 is 8. So that means that the halfway point is going to be 4 units down. So that would be at y equals -1. So right here. So y equals -1 for the midline. And again, it's just the average of the max and the min. So you could find it also just by adding the max and the min and dividing by 2. And that would end up being -1 as well. Okay, once we find the midline, we can find the amplitude pretty quickly, because the amplitude is just the distance from the midline up to the highest point or down to the lowest point, which is 1, 2, 3, 4 units. So the amplitude is 4. The frequency is how many times the cycle repeats itself from 0 to 2 pi. So let's see. you kind of see, I don't want to erase all of this, but okay, so you can see that the graph starts at the midline right here. It goes up, it comes back down, and then bam, right there is where it repeats itself. And then after that, it's the pattern one more time, goes up, comes back down, and then it finishes its second like kind of repeat at 2 pi. So the frequency would be 2 because there's 2 cycles within that like span of 0 to 2 pi. And then we can use that formula of 1 over the frequency times 2 pi to get our period, which you can also cross cancel to simplify. So like the 2 and the 2, you could divide them both by 2 to get 1. And then it would just be 1 times 1 pi, which is just pi. Okay, there's another way of finding period, especially when you're presented with the graph. It's how long the graph takes before it starts to repeat itself. So like you can see, I didn't mean to erase that much. You can see the graph goes up, comes back down, and then right here is where it starts to repeat itself again. And I know it's kind of hard to see, it's like cut off from the graph, but right there is pi. So the period is pi. So sometimes you can see it from the graph. If you can't see it, you can always fall back on that formula. So then now we just have to go ahead and take each value and put them in. I'm not going to scroll back and forth between what each letter means. You hopefully have it on your paper. But the amplitude is A. The frequency is B. And then the midline is K. So we just have to put all those in there. So it'd be Y equals 4 for the amplitude. And then times sine. B is 2x, and then, or the frequency was 2, so 2x, and then plus k, but the midline is -1, so k is -1, so -1. So the a in front, that's the amplitude, the 2 in between the sine and the x is the frequency, and then the midline is that -1 at the end. So y equals 4 sine of 2x -1.